All right, to the people watching this video, we just got done writing down yesterday, or whatever day you were with us last, these 5 theorems. So there's 3 of them right here, and we have the corresponding alternate interior, consecutive interior. Normally we're saying that that if the lines are parallel, then the corresponding angles are the same. So that's what this guy says right here. Or if the lines are parallel, then the alternate interior ones are the same, okay? When we're doing the converse, which is what we're doing in this section, we don't necessarily know that they're parallel. We're given the angles and we're trying to figure out if they're parallel or not. So like we would do like this down here. Let me get rid of some of these. And we talked about how like if that's 70 degrees and this is 100 degrees, right? Like would those 2 lines be parallel? Well, we said, well, if this is 100 down here, then this would have to be 80, and this guy doesn't match that guy. So those aren't parallel. What's actually happening is something more like this and this line, okay? So one of them is slanted a little bit and one of them is straight, okay? So we're trying to prove whether they are parallel or not by using those things. So if the corresponding angles end up being the same, if that was in fact 70 degrees, then these would be parallel. And that would be because of theorem 319, okay? The corresponding angles theorem, that type of thing, okay? So we're going through and we are proving stuff. There's 2 more on the back side. These are the converse ones. There we go. Let's go to some examples. Example 1, here we go. We've got this little diagram that we are looking at. There's an ABC here for this. They say if angle 2 matches angle 8. If angle 2 matches angle 8. First and foremost, which 2 lines are we thinking are probably parallel? If angle 2 matches angle 8, which 2 lines are we in question that they're parallel? A and B. We're not talking about this line right here, right? M doesn't have anything to do with this. L is my transversal. A and B are my 2 lines that we're assuming maybe are parallel, okay? So because angle 2 and angle 8 are congruent, A is parallel to B because what are 2 and 8 in relationship with each other? What are 2 and 8 together? Alternate? What? Interior. They are alternate interior angles. Okay? They're alternate interior angles. So by the converse of the alternate interior angles. Oh, I forgot to write it. Will you bring me a pass? By the converse of the alternate interior angles. Now, which theorem is that? Theorem what? Number 3 point what? Alternate interior angles. Which one is that? Which one?
Alternate interior.
Yeah, alternate interior. The converse. The converse. The one off to the side. 3.22? Perfect. So if you don't want to write this guy in here, you can write theorem 322. Got it? Okay? All right, the next one is talking about 3 and 11. Let me erase. So angle 3 is here. Angle 11 is here. Okay? All right, we are not talking about line B. He has nothing to do with it. A is now my transversal, and L and M, those are my parallel ones, okay? So, the ones that we're looking at being parallel. So L and M are parallel. All right, 3 and 11, what are they to each other? Are they corresponding? Yep. Rip him off. Go take him back, would you please? Thank you, dear. Okay, 3 and 11. You said they're corresponding. I agree with that. So we've got, because 3 and 11 are corresponding angles of lines L and M, because they're the same by the converse of the corresponding angles, which is theorem what? What's 319? Okay, by theorem 319, we have that L and M are parallel. All right, last one. 12 and 14. They say that 12 is the same as 14. 12 is here, 14 is here. Which 2 lines are we looking at being parallel? 12 and 14. A and B, right? And my transversal is M. So we're not looking at line L. We have nothing to do with line L. Okay, M is my transversal. It says 12 and 14 are what? Alternate exterior. They are alternate exterior. So by the converse, what's the converse theorem? Converse of alternate exterior. It's on the back page, I think.
320.
320. By theorem 320, we know that those lines are parallel. Because those are the same measure, they would have to be parallel. Okay? All right, good? All right, let's solve for some stuff. Go to the next example on the next page. Example 2. It says, from the figure, you know that line D is perpendicular to line E. Okay, so this guy is perpendicular to this one. We know that because of the right angle box. Okay, now they say find what angle, what Y would have to be in order for this guy to be parallel to this guy. Okay, if the one straight up and down is perpendicular to this one, in order for these two lines to be parallel, would this one have to be perpendicular to this one as well? Yes. So this is a 90-degree angle. And this 4y plus 10 is this angle right here. So he would have to be 90, right? It's like kind of like the rungs on a ladder, you know? They would have to all be 90-degree angles. So they say 4y plus 10 equals 90. 90 equals 4y plus 10. Let's solve, and I'm going to follow their work. Usually I don't. 80 equals 4y divided by 4. So y is like 20. Okay. All right, now, what theorem did we use that we know? How do we know that that's the case? Like if it's perpendicular to one, why is it perpendicular to the other? If they're parallel, that type of thing. Do you remember what that's called?
Perpendicular transversal.
It's the perpendicular transversal theorem, but the converse of it. So 323.
Yep.
It's the opposite. We're trying to prove that they're parallel, right? So theorem 323 is that one. Do you see how that works? Okay, there you go. All right, next, let's do A on this check one. So here we are. Do you see what this is pointing to? 6x minus 3 is this little bitty angle right here. And 2x plus 1 is this little bitty angle right here. What are those in relationship to each other? They're corresponding, okay? So we're going to use the converse of corresponding. Which one is that? Theorem 319. Okay, theorem 319 to find out what x is. So theorem 319 tells me that's true. What do we do with those two things? Like, what do we do with 6x minus 3 and 2x plus 1? They equal each other, you betcha. 6x minus 3, 2x plus 1. Let's subtract the 2x and add the 3. So I've got 4x equals 4, and x is 1. X is 1 because of theorem 319. Okay, got it? Okay, this next one, B. Okay, 4x plus 6 is this little bitty angle right here. This 2x plus 1, 52.4 is this little angle right here. And this guy is 9x minus 12. Okay, what shall we do? Okay, good question. Find the measure of LMN. LMN is this little bitty right here. We want to find the measure of that thing. Question mark. So that we want to find x. Now x could be whatever it wants to be probably, but it has to be a certain number in order for these two lines to be parallel to each other, right? So what shall we do? What?
Set LMN to RST. Set them equal.
Set them equal. So this guy right here is equal to this guy. Why? What are they?
Because they're corresponding.
Nope.
Exterior.
Mm-hmm.
Alternate
exterior. Yep, you betcha. Theorem, which one is that? 320? It's on the back page.
Yeah.
The converse. 320?
Yeah.
Yep, 320. Okay, theorem 320. All right, let's solve. Set them equal. 9x minus 12 equals 4x plus 6. Okay. I'm going to subtract 4x. And I'm going to add the 12. So 5x equals 18. And if I divide by 5, that is 3 3/5 or 3.6. You betcha. Guess what? 3.6 is an answer.
But it's not.
But it's not the right answer. You see what they do to you? They're awful. You get that question on the ACT, your brain automatically goes to like, oh, the answer is A, and you circle it and you move on. Even though you did all the steps right, you did it exactly the way that you were supposed to, and you didn't finish the problem, but they gave you, like they tried to trick you into putting that as the answer. No. So what do you got to do now?
Plug it back in.
Plug it back into which one?
Either one.
Technically either one. This is the one that we're trying to find, 4x plus 6. So I'm going to plug in 3.6 in here, plus 6. 4 times 3 is 12. 4 times 0.6 is 2.4. That's 14.4 plus 6, which is, did you follow that? 20.4. Hey, look at that. That's B. Okay. All right. Now, wait a second. Before we move on, why did they give you this? 2x plus 152.4. What?
Make you put for like supplementary.
Or you could.
Yeah. Now, here's the deal. Yeah, they put that there because technically this guy is supplementary to this one, right?
Yeah.
Okay, right? Like those two would be supplementary. But the problem is, if I add those up and set it equal to 180, the fact that those two are supplementary, does that necessarily mean that these two lines are parallel to each other? Not necessarily, right? And that's what we're trying to do. We're trying to solve that the lines are parallel. So yeah, I could add them together and set them equal to 180, whatever, but that doesn't have anything to do with line A being parallel to line B, right? Okay, so that's the choice that I'm going to do. So then we're not going to use that guy. They're putting information in there that we don't need. Got it? Okay, next, example 3, last one. Proving lines parallel. To move in a straight line with maximum efficiency, rower oars should be parallel. Refer to the photo at the right. Is it possible to prove that any of the oars are parallel? Justify your answer. All right, so they have this line going right here, and they stop it here, but I'm going to make it go all the way through. So I'm going to make a straight line go all the way through there. Okay, can you see my orange? Okay, and then I've got this line. I'm going to make it go all the way through. We're trying to prove that those two lines are parallel, or see if they are, I guess. This guy, I don't know if you see this little red line right here, he is a transversal. And then the only thing that we have labeled is that this is 50 degrees and that this is 124 degrees. All right, so let's talk through this. Are those two lines going to be parallel? Ethan's shaking his head no. How did you arrive at that conclusion?
Not added up to 180.
Right, so if this is 50 right here, then I'm going to pop him over here. I'm going to say that that has to be 50 because those are corresponding angles, right? Corresponding, okay? So if that's 50, then that would have to be 50. And how do I know that that's not going to work? Yeah, these two are a linear pair right here, this one and this one. And 50 plus 124 is 174, and that's not going to work, right? So they said something to the effect of the angle that forms a linear pair with 50 has a measure of 180 minus 50 or 130. So they looked at it and they said that this guy would have to be 130 in that case, and he's not, right? Because of like corresponding angles in the middle there, therefore it is not possible to prove that the oars are parallel to each other. So they're not quite parallel to each other. They are not moving with maximum efficiency because they're not completely parallel. Huh, interesting. Okay, that's all. Homework is 2 through 16 evens. It's short, I think, maybe. Okay, that's all. All right, goodbye people watching this video.